I can determine if two triangles are similar by angle-angle and side-side-side similarity theorems. So similarity is different than congruence. This word right here, similarity, okay, you pronounce this symbol like this word, similarity. So two triangles are similar if their three corresponding angle pairs are congruent and their three corresponding side pairs are proportional. That means they have the same scale factor. We're going to dive into what that really means now, but let's first access what we already know. Let's talk about congruent. Congruent, the symbol, is this. You speak it congruent. The symbol for similar is this. You speak it similar. Now, the definition for congruent, you have the identical shape and size. Specifically, that means your angles are identical and your sides are identical. However, for similar triangles, we do have identical shapes. So it's an identical shape. However, there are different sizes possible. That's the big difference. Different sizes possible. Think of a triangle being blown up or shrunk. So the angles are still going to be identical. They're still going to be congruent to each other. However, the sides are now going to be what we're going to call proportional. So proportional is kind of having the same scale factor. Let's dive in here and take a look. Look at the triangles over here on the left. So I had to cross out an error. Forgive me on that one. You got a 30, 60, 90, another 30, 60, 90. All the angles are the same. And then also the corresponding sides are the same as well. So these two triangles are congruent. All six corresponding parts are congruent. However, over here, these triangles are not congruent. While they have the same angles, they do not have the same sides. And that gives them a different size, but still the same shape. And that's similar. Specifically, if we want to take a look at this, you have to go in an order, and it doesn't matter if you have call this triangle 1 and this triangle 2, or this triangle 1 and this triangle 2. I can go in this order for now. It really won't matter. But just notice you have the same three angles, and you have exactly the same similar triangles. This one just was blown up a little bit. Now the sides do have the same scale factor, and if you were to take a look, that scale factor here, how does 2 get turned into 6 times 3? Square root of 3 gets turned into 3 square root of 3 times 3. 1 gets turned into 3. You got it, times 3. However, seeing that scale factor isn't always that easy. So I'm going to come down here and do a little comparison of triangle 1 to triangle 2. Okay, and I'm going to look at the small, medium, and large sides. So, for example, my small sides here, across from the smallest angle is the smallest side. Let me compare these right here. This is going to be my small. Triangle 1 is a 3. Triangle 2 is a 1. Let me now go after my medium. So across from the 60. Okay, and I have over here my medium. I have 3 square root of 3. Again, I have to be consistent. Triangle 1 to triangle 2 over 1 square root of 3. And then finally, I will go for the larges here. And those, I'll zoom in a little bit better. That would be 6 in triangle 1 to 2 in triangle 3. Now they all look different. However, if something's proportional, then their ratios are going to be congruent. So the ratio of these corresponding sides, and these corresponding sides, and these corresponding sides should all be the same. And we often have to reduce to be able to see that. So let's see if they're all equal. This is still just 3 over 1, but if you reduce here, that's 3 over 1, and if you reduce here, that's 3 over 1. So they are all proportional. And if they're proportional, therefore they are similar. One was blown up a little bit by a scale factor of 3 in this case, or 3 to 1. Now some people say, okay, we have what's called a 3 to 1 ratio. And that's this triangle to this triangle. However, if you flipped it around, if you had flipped your triangle 1 and triangle 2, you'd end up having a 1 to 3 ratio. It just depends which way you're going. Here you're going times 3, here you're going times 1/3 because you're getting smaller. Again, if you're getting bigger, you're multiplying by 3. If you're getting smaller, you're multiplying by 1/3. Okay? So, one other thing of note, if you come back over here and you look at all of these sides, you can look at their small, medium, and large, and they're 1 to 1, square root of 3 to square root of 3, and 2 to 2. And if you reduce all of those, you get 1 to 1. So it turns out that congruent triangles are also similar. They are, with a 1 to 1 ratio. But are all congruent triangles similar? Yes, but are all similar triangles congruent? No. Okay, so if we come down here and finish this off, we're looking at angle-angle similarity. If you have two angles in one triangle congruent to two angles in another, then the triangles are going to be similar. And why only two? Because if you have two angles, can't you always go and find the third by the third angle theorem? Yes. So if two angle pairs are congruent, then the third angle pair must also be congruent. So you can think of AA as AAA. You got three angles in common and congruent, you're going to have similar triangles. One's just probably blown up or shrunk. Side, side, side similarity. Notice I put the word similarity. I don't want you to think congruent. These sides are not congruent. Okay? These sides are proportional. So the three corresponding sides between the two triangles are proportional. Then the triangles will be similar. So these are the two ways right now that we're going to sort this out to see if we have similar triangles. Go ahead and we'll try a couple really quickly. Some guided practice for examples and non-examples. If you look up here and you're given two angles, you better make sure you fill in the third angle. So if I make sure these sum up to 180, angle C's measure is 55, angle T's measure is 25. And if you look, angle A is congruent to angle T, angle V is, not angle V, angle C. I have to go in the same order, so angle C is congruent to angle V. I just picked two angles. I don't even have to look at the third, but by showing that two of their angles, two of the corresponding angles are congruent, then I know by angle-angle similarity that my two triangles will be similar. Specifically, triangle ABC and triangle TUV are similar. Now, if I look over here, if I come down here for a non-example, if these sum up to 180, angle E's measure is 10 degrees, while angle J's measure is 20. So they share the 140s, but they don't have any second pair of angles congruent. So these triangles are not, similar because they do not have at least two angles congruent. Gotta have two. Now, let's come up here and look at SSS similarity. Again, you go in small, medium, or large, trying to figure this out. So the smallest side right here, these are oriented the same way. If I rotate it or flip this like I did over here, it can be more confusing, so be careful. So my small, how about I call the bigger one again, triangle 1 to triangle 2. It won't matter. Okay, triangle 1 to triangle 2 right here. I'm going to go ahead and say 9 to 3. So my medium is going to be the 4 and the 12. So I'm going to say 12 to 4 again, triangle 1 to triangle 2. Keep the order, triangle 1 to triangle 2. And last, for my large, I'll say 15 to 5. They don't look the same, but if you reduce them all, 15 over 5 reduces down to 3 over 1. 12 over 4 is 3 over 1. And 9 over 3 is 3 over 1. So because all of these are equal to each other, we can say they are proportional. Whoa. Try spelling that one again. They are proportional. Therefore, triangle XYZ is similar to triangle ABC by side, side, side. Similarity. Scale factor here is 3 to 1. If you're going from if you're getting bigger from small to large, it's a 3 to 1. You'd be multiplied by 3, and you're multiplying by 1/3 if you're going from large to small. Right. So look at a non-example. You line them up the exact same way. Triangle 1 and triangle 2. If we do that, here's my small. It's going to be 5 compared to the 10, so I have to go 10 to 5. Triangle 1 to triangle 2, which reduces down to 2 over 1. Let's see, my medium is 12 and 18, so 18 is 12, which reduces down. If I divide both by 6 to 3 over 2, and my large is 26 over 13, which is 2 over 1. And while these first two, first and last, are the same, the middle one's not. So these are not equal. They're not proportional. Therefore, not similar. Okay, so when you have side-side-side similarity, go ahead and set up your 3 ratios and make sure they're all equal to each other to be considered proportional and therefore similar, or look for angle-angle. If they have 2 angles in common, you know the third by the third angle theorem has to also be congruent, and that would make them proportional as well. Good luck.